I just completed my first SketchUp plugin, which is a plugin to export G-code paths directly from SketchUp, and which is optimized for laser cutters. Probably sooner or later I'm going to expand on that and create a program maybe for CNC mill and add more features to this this laser plugin. But for now, it's your basic functional laser cutting program. It compensates for the beam width. The G-code path it creates is offset to the outer edge of the faces that you put into it. Basically, if you create just a square but without a face, that actually won't work with my program for now. What it's optimized to do is to take a drawing which is created on the zero plane, like it's a flat drawing in SketchUp. It will export faces, and what it also does, which I've found lacking in other G-code exporters that I've used which aren't actually integrated in SketchUp, because it has the awareness of where the face is, it will offset to the outside of this face, but then on a hole in the face it will offset to the inside of the hole. So all your dimensions should be precisely how they are when you put them into SketchUp. And what it also will do is make sure that the outer edge of each shape is cut last within that face. So basically, if you have any holes in a face, it will do the hole first, and then it will cut the outer edge. And that's because what I found in the past, that if you cut the outer edge first, the piece falls slightly out of the, for instance, sheet of acrylic that you're cutting in, and then all the inner holes are slightly wrong in relation to the face. Anyway, enough waffling. I'll just show you how to set the program up. So first of all, I'm going to show you how to install the extension. This is just like you would do with any SketchUp plugin. Go to SketchUp, Preferences, click on Extensions, install an extension, and click on the RBZ file. Then obviously say you want to install the extension and click OK. Now you might have noticed I've already obviously got my extension installed, but otherwise this would be exactly the same process you go through. The file I've got here, which I may include in the links at the bottom of the YouTube video as well, is a little test pattern I came up with to help you calibrate the laser cutter. Because the first thing you're going to want to do with this extension is to set up the parameters to work with your particular laser cutter. I've got one of the sort of generic Chinese laser cutters with a 40-watt tube in it, but the main thing you want to know is what speed you can cut at neatly and the beam width. So what you do to create a G-code file to send to the laser cutter, it's quite simple. Just go to the Tools menu. This section here is the section created by my plugin. The main one you're probably going to use is Export G-code from 2D Drawing. Now this one creates a toolpath from two-dimensional shapes that you lay out on the very bottom of your Z-axis, basically kind of on the flat zero plane of your of the SketchUp 3D space. Anyway, I'm going to click Export G-code from 2D Drawing. It's quite a lot of parameters here. Most of these you probably won't have to worry about, but the top one is very important to calibrate the shape that comes out of your laser cutter to your drawing precisely. Obviously, a laser cutter removes, there's some wastage of plastic when the laser cutter cuts out of acrylic, for example. I've set mine to 0.14 of a millimeter. That's quite a small amount, but it's, if you want to get very, very precise shapes, it's important to compensate for the beam diameter when you're cutting. Feed rate between paths, that controls the travel speed when the laser isn't cutting anything. So that's just set pretty high. That doesn't really matter. You want to, if you want to cut quickly, then you want the cutting head to be going as fast as possible when it's not actually doing anything. However, the feed rate while the laser's switched on is 2 millimeters a second. I can probably calibrate that is sort of tune these parameters up so that I can cut faster. But for now, I'm just kind of going for the neatest shape I can get and then working upwards from that. And that's why I'm using 2 millimeters a second. Passes over each path. I found that this lets you, if you go over the same shape several times, taking off a small amount of acrylic, for instance, at a time, that gives you far less of a kind of V-shaped cut hole. It gives you straighter edges on the cut than if you just try to go through the whole thing in one go. A 40-watt laser is easily powerful enough to go through 3mm acrylic in one pass, but it makes a really bad edge if you do that. So what I tend to do is set the laser very low and go over each shape 3 times with the laser, and I tend to get pretty nice edges that way. The rest of this stuff is a header for the G-code file and a footer. This probably will be specific to your laser cutter, but I'm afraid I can't really help. If you're not too sure about G-code, there's not much I can do to kind of give you the exact settings that you're going to want to use. But just for an example, mine G21 code just tells the machine that the parameters are going to be coming out in millimeters. My script exports in millimeters, so that's quite important. Some machines are millimeters by default, some machines are in inches by default. But just to make sure, I've specified inches, no, millimeters, sorry. G20 would be specifying inches, G21 is millimeters. Second header line, to be quite honest, I'm not totally sure what all of this stuff does. But essentially I've got another G-code program which I know produces G-code that works with my machine. I've basically replicated what they put at the top of their G-code files. It'll be things along the lines of use absolute positioning, etc. The footer, this is at the end of your G-code file after all the shape instructions have come out. This is really important. At least on my machine, the laser doesn't switch off unless you send it a G0 command. So that's all this one does. It's G0, X0 and Y0. And that just returns the cutting head to your origin position as well as turning off the laser. M2 is just a very general purpose standard machine off G-code. Anyway, you would just click OK. You get a save dialog. The default name for the file is just your SketchUp file name .gcode, but you can just change that as fits you. There are other extensions which work with other file extensions which work with various CNC machines as well, and just click save. The pattern I've got here, yeah, this is a pattern which will let you tune up your laser cutter. It will get your beam width set up fairly precisely, because you have 2 parts which should ideally, if they're cut out very precisely, they should fit together tightly, but without having to force them excessively as well. In the next part of the video, I'll just show you the tuning up process where I got my beam width and cutting speed to something sensible. Saved down in that location that you choose is a G-code file like this. It's essentially, it would be possible to open it in any text editor. It's just a line of instructions for the machine. You'd obviously need a laser cutter which is compatible with G-code. There's going to be more videos on this channel about actually retrofitting your laser cutter so it could take G-code if it doesn't already. Anyway, that's your G-code file. Just to make sure you've got the right cut path, that nothing went wrong with the export, you can actually use my plugin to check that. So you'll want to create a new file in SketchUp. This has just got this MakerBot example thing there, just get rid of that. Go to Tools again and go to Import G-code to check paths. Just locate the G-code file you created, click on that, and you should see something that looks pretty much like the drawing that you put in, except you'll notice slightly larger. That's because of the compensation for the beam width. So if you measure across it, the original piece was 30 millimeters high. This one is 30.25. It was 1 centimeter wide, but the path is 10.25. So that's to be expected. It will have a little bit extra, but it should look pretty much like the original drawing. To get the G-code file sent to your laser cutter, you'll probably have your own way of doing this. But what I'm doing is using a RepRap program called Print Run. You just go to Load File, locate the G-code file. So this was my first cut with the G-code that came out of the machine. I was cutting very fast just to see whether it could do it or not. But on this one I didn't actually set the beam width high enough, so it didn't come out at all. This was a cut at 10 millimeters a second and using a slightly higher power beam. This time the pieces did actually come out of the acrylic okay. Now at this point the cutting power was turned up too high. You can see the pieces fit together really well when you turn them back to back because of that V shape that the cuts develop, but then they're far too tight if you try to fit them together the same way around. Now to reduce the V shape I turned the beam power down. Luckily I already know what setting works for 2 millimeters a second cutting speed. So I just went into my software, exported the drawing again, but changed the 10 millimeter feed rate down to 2 millimeters while cutting. You'll probably find that a lower cutting power produces a better quality cutting path, which is also thinner, so the amount of material removed will be less. So these pieces do not fit together very well, because the software is expecting far more material to be removed from the edges by the beam than actually was. They fit together pretty well opposite way around, but that's because of the V shape still present in the cutting path. The beam width was sent to 0.25 of a mil. I just changed that to 0.10, that is a tenth of a millimeter. This time the pieces fit together a little bit too easily. That told me the machine was taking off more material than necessary. That is, that the beam width was actually larger than the one calibrated in the software. So I went back in, exported the file again, but now with 0.14 beam width. And this time they actually fitted together pretty well. They were sort of they were tight. You could tell there was good contact between the pieces. That would be important if you were going to glue them together with acrylic cement, for instance. And you see that either way around they fit together pretty well, and that tells you that the edge of the cut was straight rather than V-shaped. Now that was all looking pretty good, but I decided to get a vernier caliper just to make sure of the dimensions of the piece. It's supposed to be 5 millimeter teeth width, so that's pretty much bang on. The inside of the teeth, I had a bit of trouble measuring it accurately. I'm a bit clumsy with the vernier caliper. but that came out pretty much as a 5.1mm gap, so I was pretty happy with that. There's so many different measurements flashing up there, you'll just have to pretty much take my word for it. That's 5.1mm. Well, I hope you found that video useful. As I said, I'm going to extend the capabilities of that plugin to do a lot more around CNC machining in future. But for now, if you click the link in the description of the video, you'll go to my website and you'll be able to download the RBZ file, which lets you install the plugin in SketchUp, and also a .skp file of the test pattern that I used in the video, which should help you calibrate the beam width. If you found that useful, please do subscribe to my channel and like the video. There'll be a lot more about laser cutting, how to get the most out of your laser cutter on this channel in the near future. Thank you and goodbye.